this is Sophia, and we will try to solve a polynomial equation problem from our homework in home. As soon as I start writing on my tablet, you will be actually not seeing me anymore, but you will be seeing my ceiling, so just be aware of that. So this is a homework problem, and we are asked to find the zeros of this polynomial function algebraically. Now, we are not allowed to use a graphing calculator, and also this will be the case for our exams and tests. So we have to do it algebraically, which means it will we will have to do extra work. The rational zero theorem says that if a polynomial has rational zeros, then the zeros will be fractions with numerator the divisors of the constant term, which is 24, and denominator the divisors of the leading coefficient, which is, in our case, 1. So actually, if there are any rational zeros, then they have to be whole numbers because the only divisors for 1 are 1 and negative 1. Therefore, our possible rational zeros are plus or minus 1, that's a divisor of 24, plus or minus 2, plus or minus 3, plus or minus 4. The next divisor of 24 is 6, or 8, or 12, or 24. So obviously, algebraically, this is how we are going to try all of them to find which one is a zero. However, in a particular exam, let's say our final exam, I will give you the screen of my graphing calculator where I would have graphed this particular function. And I see here that this graph obviously has 3 real zeros since it's a cubic equation. And of those zeros, it looks like it's going by close to negative 1 and then close to negative 4 and negative 4.5. So since it doesn't go exactly through negative 1, I know that negative 1 is not a rational zero. Also, I know that all of these other values are not the rational zeros, and I will try negative 4 as my first guess. And this is how I will shorten the process. So the only reason I would use my graphing calculator, or the only reason the test will give you an image of the graphing calculator, is so that you don't have to try so many before you can guess. So I'm going to guess that negative 4 is a possible rational zero, and I'm going to do synthetic division. If I am correct, the remainder of the synthetic division will be equal to 0. So in synthetic division, I dropped the leading coefficient, I multiply, I add, I multiply diagonally, and I add, and I multiply, and I add, and if my last sum is equal to 0, this is the remainder, and that means that I did indeed find a 0. So negative 4 is a 0 of this polynomial, and I will list it in my answer. Also, I know that the quotient is of degree 1 less, and it will be obviously a quadratic, 1x squared plus 6x plus 6. And this quadratic is not factorable over the integers, so I'm going to use quadratic formula to find its roots. So the roots are negative b plus or minus square root of b squared minus 4ac divided by 2a, and that is negative 6 plus or minus square root of 36 minus 24 divided by 2. The discriminant is 12, divide that by 2. I can simplify the root, so I will have negative 6 plus or minus, the square root of 12 is 4 times 3, the square root of 4 is 2, 2 square root of 3 divided by 2. And remember that this 2 has to divide every term in the numerator if you want to simplify. So minus 3 plus or minus the square root of 3. So these are the other two zeros of the function. Therefore, in my answer in ohm, the zeros separated by commas will be -4, comma, -3 plus the square root of 3, comma, -3 minus the square root of 3. The exam is going to ask you to also provide the linear factorization of the polynomial. The linear factorization of a polynomial is the product of the leading coefficient a times factors, linear factors, x minus your first 0, x minus your second 0, x minus your third 0, etc. And you only have 3 zeros for a cubic polynomial. Your leading coefficient in this case is 1, so 1 times x minus -4, which is plus 4, x minus -3 plus the square root of 3, which will be plus 3 minus the square root of 3, and x minus -3 minus the square root of 3, which will be plus 3 plus the square root of 3. Notice that this is not requested in this particular homework problem, but it will be requested in the exam.